This is my little smart device. I built it from scratch with a simple idea: make something useful, interactive, and actually look good on my desk. It has 4 buttons, a custom interface, a light, a clock, and even an alarm. But this isn't just about making a gadget. I wanted to see how far I could take a simple idea and turn it into something that actually feels like a real product. So let me show you how I built it. This is my little smart device. Before building anything, I had to figure out what I actually wanted this device to be. I wanted something for my nightstand. Small, simple, but actually useful, not just a clock. I wanted it to show the time, let me set an alarm, and control the light in the room, all from one little device with just 4 buttons. That was the plan. Now I just had to build it. Next came the enclosure. I designed it as a hexagonal case, a shape that stands out a bit more than a boring rectangle while still being compact enough for a nightstand. On the front, that's where the screen is going to sit, right in the middle. Above it, I'll leave a small opening for the light sensor, the photoresistor, so it can read how bright the room is. And below the screen, that's where the 4 buttons will go. One with a light icon to control the LED, a plus and a minus to adjust the time, and one marked M for menu to switch into edit mode. If you flip it over to the bottom, that's where I'll place the USB-C port for power, right next to an opening for the light to shine through. On the side, that's where the power switch will go, and on the back, I'll add a few screw holes to close everything up properly once it's all assembled. Now here's the problem I ran into. At first, I wanted to add a small raised bump on the front, just above the screen, to engrave my channel name into it. Looked nice in the model, but once I printed it, that bump needed supports underneath, and once I removed them, the surface came out rough and honestly just didn't look good. So I scrapped that idea and just kept the name flat, directly printed into the front panel instead. Simpler but way cleaner. With the enclosure figured out, it was time to design the electronics. And instead of connecting everything with a bunch of loose wires, I decided to design a small custom PCB. Here's the Arduino Nano, the brain of the whole device. Here's the RTC module, which keeps track of the time even when the device is unplugged. And here's the screen, where everything gets displayed. For all the other components, MOSFET, BMS, charging module, and so on, I'll leave the full list in the description below, so you can check the exact parts if you want to build something similar. Now, instead of connecting everything with a bunch of loose wires, I decided to design a small custom PCB. This board is built around the Arduino Nano. I didn't recreate the Nano itself, I just designed a PCB that holds it and organizes all the connections around it. There's a spot for the RTC module, a connector for the screen, and a section for the 4 buttons. For the LED, I added a MOSFET, because the Arduino alone can't push enough current to properly power the 3 LEDs I'm using. The MOSFET handles that, switching the higher current on and off while the Nano just sends the signal. Do you hear that? With the design finished, it was time to make it real. I loaded up the file, picked my settings, and hit print. Do you hear that? My sanity. And just like that, the shape I'd been staring at on my screen for days was finally something I could hold in my hands. Now let's talk about the interface, because this screen has a pretty unusual shape. It's a 2.25-inch TFT LCD, 284 by 76 pixels, driven by an ST7789 over SPI, so it's wide and short, like a long strip, and I had to design the layout specifically around that. Quick word before we dive in, this part of the video is sponsored by Laka, the tool I used to build this whole interface. I designed the whole graphic interface using Laka, a tool that lets you build the layout visually and generates the code for it, so I could just drop it straight into my program. For the colors, I went with orange and a deep blue, not sky blue, something a bit richer, because I wanted something that actually catches the eye instead of a plain black and white display. I added white accents in a few key spots too. The time is in white, and the alarm section is in white as well, so they stand out from the rest. At the bottom of the screen, there are 4 icons matching the 4 physical buttons, so even in the dark, you know which one does what: mode, plus, minus, and light. And if you want to try it out yourself, use the code on screen right now for 20% off. Now, funny enough, small mistake here. During final assembly, I accidentally swapped the mode button and the light button, so on the screen, the first icon says mode and the last one says light, but in reality, the first physical button turns the light on and the last one switches the mode. Not a huge deal, I can fix it in the code whenever I want, but for now, let's just say it keeps you on your toes. And of course, I added my channel name on the screen, along with a few other small graphic details to make it feel finished. Now let's get into the code. This is where everything actually comes to life. Quick note on Laka. If what you designed is fairly complex, like an animation or something more advanced, it might give you a separate file to download, which you'd need to drop into your library folder so your programming software can use it. In my case, my design wasn't that complicated, so Laka just gave me the code directly, no extra file needed, so just keep an eye on whether it gives you a file to download or not, depending on how complex your interface is. For the clock itself, I created a variable that holds the time and displays it, a string that gets updated constantly. It pulls the current time from the RTC module and stores it in that variable so it can be refreshed and modified at any moment. Here's a problem I ran into early on. The screen doesn't clear itself automatically, so if I just wrote new numbers on top of the old ones, they'd overlap. You'd get digits stacked on digits, and it looked like a mess. To fix that, I drew small rectangles, the same color as the background, right over the old numbers before writing the new ones. That way, each time the display updates, it wipes the old value clean first, and you only see the current time. No leftover digits underneath. From there, I built the rest function by function. Each button got its own job. One for the light, one to increment, one to decrement, and one to switch modes, cycling between clock, minute setting, and alarm setting. I'm not going to walk through every single line of code here. I'll just show you the important pieces and the result right after, so you can see exactly what each part does on screen. And now, it was finally time to put everything together.
Do you hear that? My sanity about to break while everyone I know's out. On a trip, on a boat, on a lake. I'm tired of feeling all FOMO, babe. I don't even care if we stay home. Put our to-do list on ice. Crank the AC to 79 and make a little island right here. And there ain't a palm tree in sight, but there's not a cloud in your blue eyes. If we need a drink, I'll be the bartender. I got a fifth of Patron and a blender, baby. Slipping on a swimsuit is overrated.
Once everything fit, I used hot glue to secure the components in place, closed the case, and screwed it all together.
Wherever we make it. Paradise is wherever we make it.
I also designed a small stand for it, printed in black, so it blends into the design instead of standing out.
Do not disturb, I got my straw hat, babe. And you can finally pull the tags on your...
I'm happy with how it turned out, but I'm not fully satisfied. There are a few things I want to change for version 2. For starters, I don't want to use an Arduino like this anymore. It takes up too much space, and honestly, I don't have full control over everything happening on it. In version 2, I want to design everything on a single custom board. No separate Nano, no separate charging module. Just one board that does it all. I'll also switch to a better battery. And you might have noticed there's a temperature section on the display. That one's actually fake for now. The enclosure was just too small to fit a proper temperature sensor, but in version 2, I'd like to make that real. I'm also thinking about making it wall mountable, or able to clip onto a vertical bar, along with a few other features I think could make it more interesting. So yeah, I like it, but this is only version 1. I'll keep working on it for future videos. If you enjoyed this one, don't forget to like the video and subscribe for the next build. See you in the next one.